Okay, guys, so we're going back a couple of weeks. Okay, so we're going back last week or maybe the week before when we were doing Pythagoras. All right, so what we're seeing here is a circle. Okay, and we've got a line that they've given us as length x. Okay, that goes from edge to edge. Okay, now that's important. It goes edge to edge, but it doesn't cut through the center. They've given us the center. Yeah. Okay, right in the middle there. Okay, so we've got a line that goes edge to edge that doesn't cut through the center. That's called a chord. So it's a chord question. As soon as you see sort of chord question, you know you're going to be using Pythagoras. If you can spell it. Okay, you know you're going to be using Pythagoras. So the long side squared equals short side squared plus short side squared. You know you're going to be using that at some point in this question. So we're looking for right angle triangles. Now this time they've given us it fully drawn out, which is quite nice of them. Okay, so that wee triangle there, they've given us the 2.1 meters. Now that 2.1 meters they've given us goes from the center to the outside edge. That is the side along, the side opposite the 90-degree angle. Okay. It's a hypotenuse of the right angle triangle, but it's also the radius of that circle. Okay, so that 2.1 meters is not only the hypotenuse of the right angle triangle you've created, but it's the radius of the circle itself. Okay, so that gives you wee bits of information. So that's what you've got to play with. Okay, now we're going to calculate x, which is that full distance from side to side. Okay, but what we've got information-wise is enough to find out another side of that right angle triangle. So we're going to ignore the full length of x that goes from side to side and only focus on half of the chord. Okay, so we can work out half of the chord length. Okay, and call this whatever you want, all right? What are we working out? Oil or something? Call it O. All right. Now that side goes from there to there. That's what we're trying to work out. Then we're going to double it for that full length of the chord. Okay, so we've got one side, we've got the hypotenuse, we know it's a right angle. What else can we figure out? Well, we've got this 3.4 meters that goes from the surface right down to the bottom of the circle. The 3.4 meters is no use to us. Okay, we need just the short side of the right angle triangle. We just need this side here.
To see that 3.4,
yeah,
is that meant to like show the line from that top bit down to the bottom in the circle, but just outside of it?
So it shows you the depth of the oil itself. So it shows
Right.
you from the surface to the bottom edge. Okay, so it shows that whole length.
Right.
Okay, now we don't want that whole length, but what we can do is remove the radius. So we know the radius is 2.1, all right, and we know this distance here from the center of the circle to the outside edge is 2.1 meters. All right, so from the center of the circle to the surface of the oil, the one that I've drawn is yellow, okay, that can be found by doing 3.4 minus 2.1. So the yellow side there from the center of the circle, all right, center to oil surface is 3.4 minus 2.1, which gives you 1.3 meters. All right. That distance there is 1.3 meters. So now we've got the hypotenuse from the center to the edge, okay, it's across from the 90-degree angle, and we've got one of the short sides. Okay, so that is going to be one of the short sides. Now remember, write this whatever way you're comfortable with, but Pythagoras is the long side squared, the hypotenuse, equals the two short side squared added together. Okay, the inverse of that, so if we want to find a short side, okay, we can rewrite it, we can rearrange that as long side minus a short side. Okay, remember to square them. So we're trying to find that purple side. Okay, we're trying to find the purple side, that's our unknown. We've got a long side squared minus a short side squared. Calculator paper, so you can work out the calculator. 2.1 squared minus 1.3 squared gives you 2.72. All right, just the short side, so we can move the squared root. We can move the squared sign, the index, over to the other side and becomes the square root. The short side we're left with is just the root of that answer then. We're leaving us with 1.65 meters. All right, so that short side, that purple side, half of the chord, okay, is 1.65 meters. Now, full length of chord is equal to the 1.65 times 2, which is your 3.3 meters. Okay, so that's your x, all right, full length of chord. That's your x, they ask in the question. Any questions for that, guys? Cool. Okay, the second part of that question might have thrown you a wee bit. Okay. Essentially, they're looking to see where else that distance from side to side occurs. Okay, so it happens at that point, but it also happens if you were to drain that oil down. Okay, you would get the exact same distance from side to side towards the bottom. All right. That line I've just drawn on, okay, it goes from the left-hand side to the right-hand side. Okay, that's going to be the same as your distance x. Now, a couple of things I'm looking for you to understand is grasp what that question is actually asking you. Okay, so, and then work out what the depth is going to be. Okay, now that's going to happen exactly 1.3 meters away from the center of that circle. Okay, we know from the center of the circle all the way to the bottom is the radius. All right, that one there is 2.1. So what we're left with, the depth of that from the top of the surface oil to the bottom, all right, is going to be the difference between them. All right, so it's going to be our 2.1 minus our 1.3. All right, and that's it. All right, so it's a that's it. All right, so a wee bit of a tricky one, probably only worth 1 mark. Away from it. All right, but one. Yeah, it was only worth 1 mark. Okay, but one to look out for. See, when it's only worth 1 mark like that, it's going to be something simple, straightforward. So even though the wording might be a wee bit, throw you a wee bit. All right, just think about it. It's only worth 1 mark, so they're only going to ask you to do one simple calculation. All right, there will only be one step to it. Okay, you usually get marks per step. Okay, so I wanted to do that with you just because that's the last time we've seen circles. Okay, now there's another type of question they can ask when you're working with circles, and that's the worksheets that I sent out. Okay, so if I open up the worksheets. Okay, if you've got the email I sent out, just open up the worksheet.
Is it the one that shapes inside circles, that one?
Yeah. Yeah, shapes inside circles. Shapes inside circles.
Is there still Pythagoras?
Well, there's a wee bit of Pythagoras in it. Okay, so if you not see that on the screen, I'll find my mouse. Okay, this is the other way in which they can ask you circle questions. Okay, in this case, we are looking to figure out an angle. Okay, in this question, calculate the size of angle ACE. Okay, now remember, when they use letters like that, they're looking for pathways. So they're starting somewhere and they're finishing somewhere. So angle ACE is the angle which starts at point A. The angle itself will be where its C is, and the finish point is going to be E, point E there. Okay, so the angle created in here. Okay, so let's look at the rules that we need to allow us to figure this out. Okay. Let's look at the rules that we need to figure this out. Okay. Couple of things. Now, these are all rules that hopefully you're familiar with. Okay, a couple to do with circles, a couple to do with parallel lines. Okay. So let's start with a circle. Line from side to side, it goes through the middle, your diameter. Okay. Side to side, going through the center, diameter. Side to side, not going through the center, chord. Okay, we refer to as a chord. If we take any line from the center to the outside edge, it's your radius. Okay, so different lines on there. Diameter, chord, and radius. There's one that you might not be familiar with. Okay, and it's a line that touches the outside edge of a circle at one point. Oops. Okay, so it doesn't matter the angle, it doesn't matter the position, okay? Touches the outside edge at one single point. Now this is usually labelled up with letters, okay, that start and finish, but also where the point of contact is. Okay, now this is called a tangent. Okay, so that goes outside the circle. And touches it in one place. Touches it at one point. All right, again, that can go from any angle or any point. Okay, but the outside of the circle, it touches the circle at one position. Okay, now, my other circle. We'll draw a chord. I'll draw my centre. Okay. Got a chord and I've got my centre there. Now, if I draw a line from the centre to where the chord meets the outside edge, like that. Okay. That length is going to be the radius. We use that a lot in Pythagoras. Okay. But I can also create a full triangle like that. Okay, so if I've got a chord that goes from edge to edge, and I know where the centre of the circle is, I can bring a line from the centre to touch where the chord meets the edge of the circle at both points. Now that's important because that allows me to say that that angle in there, let's call it A, will equal that angle in here. Okay, so angle A equal angle B. They will be the same. So that angle in there is 30 degrees. Angle B will be 30 degrees. Okay. Now, let's quickly jump into triangles for a second. If I've got a triangle, any type of triangle, okay, all the angles, the three angles, part of that will add up to 180. So A plus B plus C equal 180 degrees. Okay. Hopefully we're okay with that. So I'm throwing circles at you, I'm throwing triangles at you. It's horrible. I'm not nasty, I promise. Okay, so let's go back up to this circle, top right circle. And we'll put in this angle C. Okay, that big angle. That angle where two radiuses come from, that centre, that origin. Okay. If we know that angle in there, okay, we can take that away from 180. Okay, the number we're left with, we can divide by 2 and we can get angle A and B out it. Okay, so if given angle C, we can do 180 minus C to get what angle A and B would be, okay? This will make more sense when we put numbers to it. Okay, now that total, if we divide that by 2, we'll get either A or B. Okay. I'm going to get rid of this option. The example. If angle C was 100 degrees, okay, so 180 minus 100, and then take that number, okay, so angle A would be 40 degrees, angle B would be the same. Okay, so that's done quite a lot in this type of rule. Okay, so it's all about bringing angles together. Okay, so angles of triangles always add up to 180. Okay, so if you're missing one angle in a triangle, you can work it out with the other 2. If you've got a chord and you've got 2 lines going from the center to each end of the chord, the angle which those make are going to be the same. Let's look at that other row I was going to look at. If we have 2 parallel lines, so 2 horizontal lines are 2 lines that go in the same direction. Okay, and we've got a line that intersects them both. This is called a Z angle. Okay, now if we get told what this angle is in here, we can work out what that angle is in there. Okay, angle A is equal angle B. That's a useful rule to know as well. Okay, so Z angles, the angles of the inside of a Z are going to be the same as each other. Okay, what else do you need to know for this? Tangents. If I've got a tangent, yeah, very often what they'll do bring a line from the centre to meet that point of contact. Now what that does, if I've got a radius coming from the centre and it meets the same point at which a tangent is going through, okay, it's going to create 90-degree angles either side. Okay, so that wee square I'm drawing on just means 90 degrees. Okay, now that's an important one as well. Another one which sort of builds upon rules I've already sort of discussed. I've got a line like that with a diameter. Sorry, any line will be fair. All right, and I've got a line coming away from that as well. Okay, if I've got a straight line and an angle coming off it, if I add angle A plus B, it's going to equal 180 degrees. Okay, 180 degrees is just a horizontal line. Okay. So in that, if angle B is 73 degrees, okay, you'd find angle A by doing 180 minus 73. Minus 73, which would give you 107 degrees. Okay. Thrown quite a lot at you. Okay, it's really just so you've got to reference to when we go through one of these questions. Okay. So what you need to know, what you really need to focus on is all the numbers in a triangle add up to 180. If we've got two lines coming from the centre to meet where a chord is touching the outside edges of a circle, okay, those angles A and B that I've referenced, okay, will be the same. What they often do, will bring a line from the centre to where it touches, a tangent, okay, that will give you 90 degrees. They might split a line like that, okay, so knowing that a horizontal will be a total of 180. Okay, if they split a line, they give you one of the angles, you just take that angle away from 180 to find the missing one. Okay, so Let's look at a few of the past paper questions now. This is worth 3 marks, so it's not insignificant. All right, it's not too bad. I quite enjoyed doing them. A sadistic sort of way. Okay. So we'll be combining a bunch of those different rules. So what I'm putting on the board is 22 paper. Okay, so you've got the worksheet, it's past paper 22. Is that the first one that comes in? Past paper 22, paper 1, question 4, so non-calculator. And they give you that's that information. All right, that angle in there. Oops. (60°). And they've labelled it O for origin. They like to label that. B, E, A, B, and C. All right, AB is a tangent to a circle. AB is a tangent to the circle and it meets the circle at point C. Okay. CD is the diameter from point C, where I've marked up already, to point D. Is the full diameter, and that goes through the center of the circle at O. Okay, and then you've got OE, or you've got the angle at DOE even. Okay, so D to O, O, E. Okay, that middle letter will give you your angle. Okay, so even if it wasn't drawn on, angle EOD, 68°, the middle letter will be where the angle is. Okay, so just look out for that. We're to calculate angle ACE. So when it's asking you to calculate that angle, it's asking you to follow a path. The first letter is where you start. A, we're going to C. Okay, the middle letter creates your angle. And your last letter is where you finish. Okay, so it's a journey. So A to C, C to E, and then the angle that creates is the angle we're trying to find. Okay, so calculate the angle ACE. What you have to do is use that information and determine or bring together everything that you know. Okay, now you'll get that one image in the exam and you've just to sketch on it. Okay, feel free to do other sketches on your answer paper. Okay, the answer you'll leave in your answer paper will just be the final answer, but feel free to sketch on your exam paper. Okay. Let me take them away. So that's the angle we're after. So we've only got 68°. Okay, so we get given angle DOE. That allows us to work out angle COE. The order of the letters doesn't matter. I could have called that EOC, okay, but as long as the O was in the middle, that's where the angle I'm looking for. Angle COE is 180 minus 68. 112 degrees. Okay. Now, there's a line that goes from O to E. It goes from the center to the edge of the circle, so it's a radius. O to C is a radius, and where those two radiuses are meeting the circle, there's a line C to E joining them, so that's a chord. So there's a triangle being created from O to C and O to E. Okay, there's a triangle, so angles OCE equal to angle OEC. Okay, so that's my angle OCE. That's my angle OEC. So the middle letter creates the point. Okay, now I know that all the angles in a triangle make 180 degrees. I can therefore do 180 minus my angle of COE, 112, is equal to 68. That then gets split. If those two angles are the same, that just means 68 divided by 2 will be 34. So angle OCE is equal to 34 degrees. Angle OEC is equal to 34 degrees. All right. Now, we're only really interested here in OCE. So that's the main interest one. Okay, so if I put that on, 34 degrees in here. Okay, so we're building up a picture. Now remember what angle we're after? We're after ACE. Now that 34 degrees plays a part in ACE. But what are we missing? We're missing this angle in here. We're missing ACD. Or angle ACO. Okay, it's the same. Okay, you can refer to it either way. O and D are on the same line, same horizontal line. Okay, so it doesn't matter which one you call it. Okay, now angle ACD or ACO. Okay, well that's a tangent, and there's a line coming from the center of the circle to the outside edge where that's cutting. That's going to create a 90-degree angle there. Okay, and then angle ACE, the angle that we're after, is just equal to angle ACD, which is 90 degrees, plus my angle OCE, which is 34 degrees. That's my final answer. I would write that in the exam. That's my working. Step by step, just try and build up a picture of what we're doing.
That's awful. Realise that the circle's not really that relevant, is it? It's just what's in that's actual.
Circles. Yeah, well, it tells you that it's a tangent, and it gives you a couple of. But it needs to be there. Right, 2 seconds. Any questions on that before I remove it from the screen? Okay. What we've got on screen there, guys, is just from the worksheet itself. So 2017, paper 1, question 9. Another 3 marker probably. Try do it. You've got all that information. Have a bash. Alright, so let's take 15 minutes. Okay, so let's take 15 minutes just to digest what I've just been through. Have a wee look at it. In fact, let's say 20. Let's say 20 minutes. Have a wee look at what we've just been through. Digest it and then have a bash at that, okay? Okay, so past paper 2017, paper 1, question 9. Let's have a wee look. So, they give you this 58 degrees. Okay. Now, the most difficult bit of this is not getting overwhelmed and looking out for like wee pairs for rules that you know. So the rule that I'm hoping that you know is the fact that this O centre a circle to the outside edge, okay, and the tangent, oops, I was meant to follow the tangent perfectly. The tangent creates a 90-degree angle. So O to E, that angle there, I've just drawn on, that's 90 degrees. Okay, now we've got part of that, we've got this 58 degrees, so what we're left over with will be 90 minus that 58. Okay, so just write that out. Now instead of writing the word angle, I'm going to draw this wee symbol. Okay, that's just going to refer to angle. Okay, so angle OBE is equal to 90 degrees. Angle DBE is given, that's 58 degrees. All right. That means angle OBD equal to 90 minus 58, going to be equal to 32.
So would you show your work when you're doing it, although you know it's going to be 32, you would show the fact that you're taking the bits away?
So you're working, just follow it right through. All right. Everyone following me so far? So we've worked out this angle in here, and we've worked out to be 32 degrees. Okay. Now, the other rule that we just went through, try and picture, okay, is the fact the angle DBC also equal to 90 degrees. Okay. DBC. Now, what is DBC? That's a line, oh sorry, that's an angle that's been created by a line coming from C to D, oh sorry, C to B, I can read one right, and then a line coming from D to B. Okay, so that angle in there is 90 degrees. Okay, now remember the rule that tells me that is this diameter. So I've got that diameter where that touches the circle and the outside edges. If I bring a straight line from the outside edge to a point, then bring a straight line from the other outside edge to a point, where they meet is going to create that 90 degrees. Okay. So angle DBC, you could also call it CBD, okay? It's 90 degrees. That means angle OBC is equal to 90 minus 32 is equal to 58 degrees, okay? That leaves me one more angle in that wee cluster. That angle here. And I know it's going to be 32 degrees, okay? The simple fact, there's a couple of ways you could work it out. That ABE is a tangent, that's going to meet the circle at one single point, okay? That's going to give us 180 degrees in total. But where I bring O to B, that radius O to B, okay, where that meets the tangent, where OB meets the tangent ABC, where that meets is going to create two right angled triangles. Okay, so angle OBA and OBE, 90 degrees. So I know that ABC angle is going to be 32. Lost anyone?
Yep.
Where did I lose you?
The whole kind of thing.
What makes two of us here?
So it's a lot of triangles and it's try to combine 5 rules and just building up a picture of it. All right, so try not get overwhelmed and just try to cut it down. Even hide triangles you're not using. All right, just by covering it with your hand. All right, and just build a picture up of it. So I'm just doing one at a time. I'm just looking at an angle and saying, do I have enough information to figure that out?
I think this would be if the circle just wasn't sitting there. Like,
But I need the circle
I mean,
because it needs to create that chord and I need that diameter. But yeah. Okay, now what do I have? I'm going to look at this triangle here. From the origin to C, from the origin to B. Now that's both radiuses. They're both radiuses. So C to B is a chord. Okay, so that green triangle I've got on the screen. Okay, so O to C is a radius. O to B is the exact same length, it's a radius. They're joined by a chord. Now the rule that I mentioned when we were doing that is if we've got an angle here, at one side, it's going to be the same as the angle at the other side. So the angle at the other side of that triangle is going to be 58 degrees. Run. 58 degrees. Now, let's write that. Okay, angle OCB is going to equal angle OBC. Angle OBC we found up here. Okay, so we know what that is. So that means angle OCB, the one that I've just drawn on, is equal to 58 degrees. I love 58s. Okay. Now, what we're trying to find, or what we can find, is this angle in here now. What do we know? We know that DOA is a straight line. All right. That means angle OCB that we just found out plus angle ACB equal to 180. All right, so it's a straight line. So if I split that straight line up, if I come away from it any angle, okay, the two angles that I'm making add up to 180. OCB, we've just found out, OCB is 58 degrees plus angle ACB will equal 180, or angle ACB, move that around. If I move the 58 to the other side, at 22. Okay, non-calculator, remember. One, two, three. The last thing I need to do is say so all the angles of a triangle equal 180 degrees. All right, we've got a triangle there made up AC, CD, BA. All right, that triangle I've outlined in purple. We're missing one angle. We're missing CAB, the angle that we want. So my angle CAB would be 180 minus ACB, which is 122, minus 32.
Daniel, I worked it out just slightly differently.
What I'm gonna do is I'm gonna try and follow Richard's logic, and I'm gonna try and go a different route. Okay, and just make sure that we're happy with a different route. So I've just written up what we know. So we're finding angle CAB. We've got angle DBE. Okay. And the first angle that I'm going to find will be, because I know angle OBE is equal to 90, which gives me OBD is 90 minus 58, which is equal to 32. Yeah. So same start as last time. Okay, now correct me if I'm wrong, but Richard, you said you found angle ODB next. Okay, now ODB will be the same as angle OBD. Okay, so angle ODB will also be 32. Now, why is that? The triangle that has been found is the lines O to D, which is a radius, and line O to B, which is also a radius, and they're touching two sides of a chord. So that's the triangle that I'm looking at there. So that means that angle OBD is equal to the angle ODB. Okay, so I've got that angle in here now, which is 32, which is the same as this angle. Now, Richard, did you find this angle here, so angle OBA next?
Yeah. What I did was I looked at BOD. I just did 180 minus 32 minus 32, or minus 64, if you will.
Okay,
And that gave me that.
so you found
and
this
then
angle.
Yeah, I found that one, and then I took that one away from 180 because it's a straight line through.
Yep.
8.
Okay, so you found that angle in there. Okay, so I'll just do it your path. That's absolutely fine. So angle DOB is equal to 180 minus 32 minus 32. Okay, so that's going off the fact that all the angles in a triangle equal 180. So if we've got two angles at 32 each, then we're taking that away. Okay, so angle DOB equal to 1616. Okay, and that gives you, or allows you to find angle BOA, which would be 180 minus 116, is 64 degrees. So let's just draw in what I've done there. So BOD, or DOB, whatever the angle you want to call it, is 116. BOA, therefore, is 180 minus 116, so it'll be 64. Yep. And then you said that OBA,
Yeah, OBA is 90
90.
because
Perfect.
it's a 90 because it's a radius to the tangent sort of thing.
Perfect. Okay, so what he's done there is O to B is a radius. That radius meets the tangent. Add the drawing. but that creates a 90-degree angle in here. Okay, so now we've got a 64-degree angle and a 90-degree angle, therefore we can find the missing angle. Okay, so good work. So 64 degrees, angle OBA is equal to 90 degrees because it's a radius meeting a tangent. Okay, which allows us to find angle OAB or CAB as well. Okay, OAB. Okay, because 180 minus 90 minus 64 should give us 26. Okay, and that's the angle we're looking for. So he's created a big triangle that I've outlined in yellow. Which is absolutely fine, no problem at all.
I figured out the mistake that I made earlier on when I did came up with 29 as well. I know I did wrong. Back over it.
Alright, so there may be more than one way to do it, so that is perfect. Okay, so 2015 paper one again, okay, so non-calculator. Question 3. We're trying to find angle BDF. We're finding this angle up here. Alright, so all those lines should meet at point D. Alright. My God, go away. All those lines should meet at that angle. Now, angle BDF is made up of two other angles. Okay, angle BDF is made up of angle BDE plus angle EDF. All right. So I'm going to write that. Angle BDF is made up of angles BDE plus angle EDF. Does that make sense to everyone so far? So I've just read the question and I'm just starting to build up a picture of what I'm trying to figure out. Okay, now what I'm going to say to you now is we've got the diameter D to E. Okay, D to E is the diameter. Now if I look to the right of that diameter, I've got one triangle. I've got DEF is a triangle. Okay, I've got a triangle that I can call DEF. Now, D to E being a diameter means if I bring two lines away from where that meets the edge of the circle, so E to F and D to F, well, sometimes I hit it and it gives a highlight and sometimes, all right. What that does is give me a 90-degree angle. Okay. Remember, I've got a diameter and it's touching either side. If I'm bringing two lines together to meet at a single point, in this case, meeting at F, that's going to create a 90-degree. So I've got angle DEF. 64 degrees, that's given in the question, and I know DFE. Okay. I can now find out angle EDF by saying 180 minus both of them. So I found one part of my question already. At 26 degrees is angle EDF, which is one of the angles that I'm wanting. All right, probably could have done that in green, that would have made more sense. That's linked to EDF. It's 26 degrees. All right, so that's everything to the right of that diameter. So just you're breaking it up into different triangles, and then just trying to follow your rules just to get to where you want to be. Okay, so now I'm going to look to the left. So I'm going to ignore everything that I've just wrote on it. I'm going to ignore that triangle to the right hand side of the diameter. Take my time. I'm going to look over to the left, and I'll see that angle ABD is given to me. Okay, I know that angle OBA is where a radius meets a tangent. Which means it's 90 degrees. Where a radius meets a tangent is going to be 90 degrees. So I've got a 90-degree angle OBA, and I've got part of that, which is 77 degrees ABD. That means the leftover angle and here, okay, angle OBD is equal to 90 minus 77. It's equal to 13 degrees. Right. Now, looking back from my origin, one more triangle of interest, which is O to B and O to D, and the chord that connects them. If I've got a chord and I've got two radiuses touching where the chord touches the edge of the circle, the angle at one side is going to equal the angle at the other. So OBD is going to equal BDO. Therefore, angle BDO is equal 13 degrees. So now I've got BDO is the same as BDE. Now I've got BDE, which is the other part of that original equation. If angle BDF is equal to BDE, then BDE is 13, plus EDF, which was 26, So my total angle is 39 degrees. That's the drawing.